different types. We also talked about the fact that maintenance is a great place to find energy performance improvements. One of the places auditors always check is the SEUs. What's the maintenance for the SEUs? And external service providers are a lot of times the ones who do maintenance. So it'll be a chance to talk to some interesting people. And the reality is, if it's a service contract, it may not be the same people month to month, year to year who do that service contract. So some information on how they have competency addressed can be an interesting adventure in exploration. Okay, so these are different types of maintenance. How many of you have worked with these different types? Preventative, predictive, reliability, overall, and total productive. Okay, reactive, yes. A lot of people deal with reactive maintenance. It's a very common thing. Well, when it breaks, we fix it. Okay, reactive. But these others are, of course, going to be looking at other aspects and are places where you can see a lot of performance improvement. You'll see a lot of TPM, especially in lean-based organizations. This is one of their favorite, TPM-based. As they move up into, just beyond lean, you'll start to see reliability-centered. This requires more, data-driven type approaches. You'll also see it heavily regulated industries where the maintenance is regulated. You'll see a lot of reliability-centered. Preventive and predictive are usually initial stages. You'll start to see if they're getting ready to do TPM. So you'll see these types as you work with clients.
So what's the difference between preventive and predictive?
Predictive, you're using data to say, okay, well, we know it can run for about this many hours before we do it. So you're predicting its response based on how you're maintaining it. So there's statistical loop, a little statistical loop in there. I know I change that filter every so often, so I know that this is going to last at least this long before I go in and work on it. Preventive, you've got a schedule and you spit out the work orders and you hope you get through them.
So you probably have more knowledge of this?
A little more, yeah, a little more. Yeah, experience. We'll go into preventive, yeah. Yeah, that one gives me more trouble, so I have it on a tighter schedule. Common answer in preventive, yeah. Whereas reliability based it's a reliability calculation and it's got some forecasting in it. It's actually tied to performance. Okay. Maintenance criteria, common things that you'll hear. They do filters, they do lubes, tune-ups, adjustments. It is not uncommon these days, depending on the industry you're looking at, for them to actually, maintenance, be responsible for manufacturing parts. So they may actually do the manufacturing of the parts themselves. Some of the equipment can be rather old. If it's more than 20 years old, they may not have OEM parts available. So they may actually manufacture their own parts. So in addition to doing tune-ups and adjustments, they may actually be turning parts and actually producing parts. Things that influence maintenance or things that you need to kind of understand. Operating schedules. You can't work on the machine if you can't get to it. So if my maintenance schedule is to replace filters and do lubes every 6 months, but I can't get to the machinery, I can't meet that schedule. So how does the maintenance schedule fit with the operational schedule, and what happens when they change the operations schedule? How is maintenance taken into consideration? Inspection methods and intervals, this is another fun thing. Do they just do the action because it came out of the work order machine, or do they actually do an inspection first to see if it's necessary? It may be that that machine hasn't been used for the number of operating hours originally anticipated. Work order systems, a lot of times, have been set up quite some time ago. It doesn't mean that they have been updated to reflect the current work order, the working hours of the machinery. So, you know, has it been updated lately? It could be a lot more than they anticipated. It could be a lot less. Startup and shutdown frequency, same kind of thing. If they've done a bunch of lean projects, they may have things shutting off or starting up in a different order or in a different mechanism than previously identified in the maintenance work order system. They may have equipment they cannot shut down. So how do they maintain that? That's always a fun question to ask. Severity of service, there are different things with equipment, just like there is with your car. You may have a level 1 service with your car where they're just, you know, changing filters and adding, you know, some lubes and oil. And then you may have a level 3 service where they're, you know, doing something completely different, like brake pads and belts and that kind of thing. Same thing happens with equipment. How do they differentiate in the work order system the severity of the service that needs to happen, and when does it go from being a severity of service to needing to be considered for design? Okay, so you might be replacing it or considering a new technology. And so how does that feedback mechanism work within the system? That may be something that you have to introduce. This is a more advanced concept. Starts feeding into that predictive type information, which may or may not be in place. So if they're at preventive maintenance, this will be a new construct you'll be introducing. If they're at predictive or above, then this will be something they can easily answer. So just kind of FYI, something to think about. All right, so a lot of people will document criteria for their maintenance for a particular SEU on what they want done. This is an example. I've never seen an example like this except in this course. What I normally see is, okay, for this SEU, these are the operational criteria. That's usually put in some sort of computer file. So when the operator brings up a piece of equipment, they are going to run program 1 or program 2, and it's in that file. And then in terms of the maintenance criteria, I usually pull that up in the maintenance work order system. And that's usually what I see it. I don't usually see it set up like this. There's nothing wrong with this. This would work perfectly fine. It's just not usually what I see. Some of this, I'm not quite sure why those are matched, but that's okay. So this is an example for boilers. This tends to be more the parameters that are set up since it's for a boiler. We know we're looking at TDS, pressure, oxygen, and stack temperature. And then here's the units. It's very helpful. Here's the upper limit. Here's the lower limit. These a lot of times are set by permit. So, you know, a common document control question is, where do these numbers come from? Or what happens if their source changes? Air permits do change over time. And then here's the equipment I'm using for it. Here's if it's calibrated, and here's any notes. This would be a really good example of a measurement plan. Very common format for a measurement plan. Now, let's talk about something that happens in operational controls. We have this concept in 2 places in this standard. It's called significant deviation. The term is significant deviation. There's one under operational controls. The second one is going to be in measuring and monitoring. So we have this concept twice. For CP, this is an important concept. For an organization, they can be a little confused. For an auditor, it's a fun place to go. This is a fun place to audit. Okay, so this is what it's supposed to do. Favorite audit question is, what if? So what if it is above 300? What if it's at 4,000 for total dissolved solids? What if it's outside your limits, is where we're going. So this is the limit. What if it's outside that limit? Now, numbers in energy vary. They have variability in them. So the chances that they're going to be the same are pretty low. The chance that they're going to change is pretty high. This is what we have a concept of significant deviation. If it's changing, and it's changing in a range where you expect it to change, it's not a deviation. It's a normal reaction. If all of a sudden it's normally running around 3,600 and now it's at 42, that's a big change. Is it a big change that you expected? In other words, at the end of every month it hits 42 because I've got to put the new chemical in there, and that's normal when I'm running out of chemical. It's not a significant deviation. If it hit 42 and it never in its life has been above 37, that's significant. So what's significant for TDS may be very different than stack temperature. Because if it gets to 400 on stack temperature, I'm probably starting to eat my metal stack. This would not be a good plan. So 305 might be a good significant deviation. The point I'm making is, if it's significant, depends on what it is. So in operational controls, in addition to considering what your control and criteria should be, you also have to consider what a significant deviation is. That's a point where you should take a look at what's happening. It doesn't mean you've got a problem, but it's an indicator that says, hey, pay attention to me. That's when it's significant. Now, when you look at it, then you're going to make some other determinations, like, is this significant enough that we need to find the cause and resolve it? Then it's become a nonconformity, and we're going to put it through the system where we determine cause, we find and develop a solution, and we implement that solution and check to see that it works. That's the corrective action cycle. That's non-conforming corrective action. If I just need to make an adjustment, it's made a blip, it said, hey, pay attention to me, and you paid attention to it, you said, oh, well, he had a chemical in there 20 minutes ago and he forgot to adjust the temperature. Okay? It's a known event. They have to put chemicals in the boilers every so often to keep them treated, and they didn't make the necessary adjustment. I'll whack them over the head with a pool needle later. Right now I'm just going to twist the knob. That would not need a nonconformity. You don't need a cause. You don't need to do anything. You need to remind Joe to turn down the temperature when you throw the chemical in because it's a little bit exothermic. You don't need that extra temperature going, okay? He forgot. People do that. It's okay. So significant deviations, you need to think about what they are. You need to recognize they're not the same for everything, and not every significant deviation leads to the need to find a cause and solution. Those are the three things that you have to understand about significant deviations. Now, I've used this example on an operational activity. What happens if I go back and say, what about in a maintenance activity? Because if significant deviation applies to this whole section. So what would be a significant deviation in a maintenance activity?
You're supposed to change that filter whatever time period, and you don't do it. Or you're looking for something more subtle.
Well, if I didn't change it, did it cause a problem if I didn't change it?
Maybe.
Maybe. Do I know the cause?
Maybe.
It could be that I had 42 things scheduled and that was number 41 on the list and I only got 38 of them. You know? So it could be an issue. It could be that I need to do a root cause. If not changing the filter could lead to a reason to look at root cause. And it may be a resource issue. It may be I didn't have the right filter in place, etc. If I need to determine the cause, then it could be a deviation that leads to a nonconformity that I need to find the root cause for. It could just be I didn't get to it, but it's not something that's going to be an issue that waves at me that says, hey, pay attention. So just not changing filter may not be a significant deviation if the effect of that isn't something that's going to potentially cause a problem. Or potentially create a much better situation, because deviations can be positive or negative. So hey, I used a new kind of filter, now I only have to change it every 9 months instead of every 3. That could be a positive deviation that I want to repeat in other systems. So a deviation that catches your attention for a good reason or a bad reason is the one you want to pull up. If I just missed one, may not be enough to catch my attention. It would depend. Depends. The audit answer, it depends. But it could be. I mean, but another example of a maintenance significant deviation could be if I'm looking at the work order history report and there's a system that has not had any of the maintenance items checked off in the last 6 months. That could definitely catch my attention. And that could be something I need to resolve and elevate to a non-conforming. Or it could be that I have Mark, the new guy, who doesn't know how to get back there. I need to give a tour. But it would catch my attention because nothing's been happening back there for 6 months. Another thing in maintenance that might catch my attention is if I was using 150 filters every 6 months and now I'm using 350 filters every 6 months. This would catch my attention. It would also catch my budget, but it would catch my attention. So I might say, okay, why are we using so many filters? And I might find out that they have some new wonderful products with hot particles that are floating through there and making holes in my filters. I might need a different type of filter. Okay? Make sense? Everybody understand what significant deviation is?
So what is the, does those need to be recorded?
Excellent question. So let's take a look at the standard itself. And we're in section Operational Controls 455. And what it says is where absence could lead to a significant deviation from effective energy performance. It's in A. So there is, you have to establish criteria. You have to know what a significant deviation is, but it doesn't specifically require a document. And it doesn't specifically require a record. But it would be very hard to show that you investigated a significant deviation without some record. So the most common record I see for these is a logbook.
But
Yeah.
even that is not mandated by the standard, right?
It's not mandated.
So even if they don't record, even if they don't have a
The
record.
problem with not putting it at least in a logbook is when I go to ask an employee. So now I'm talking to the guy in operations and he's running, I'm talking to the guy who's running the boiler operator. And I'm saying, okay, what happens when you're above 3,800? What happens when you get 4,000 ppm? Well, I do this, and this. Has that ever happened? Yeah, we had it happen 3 weeks ago. What did you do? So they don't have anything to hold on to. They don't have anything to refer to. They don't have anything to show you. So in an audit, you're depending on them answering that question. Well, does anybody else operate the boiler? Yep, Frank operates it on 3 days a week, and I operate it on 3 days a week, and then Joe operates it 1 day a week. We run these combination of shifts. We're not here 24/7, but we work 10-hour days, and this is kind of how we cover it. Okay. Then I come in later and I talk to Frank. Frank, has it ever hit 4,000? Well, yeah. And when does that happen? And what do you do? And if I don't get the same answer I got before, then I have a non-conformity. So the audit risk is there if you choose not to have a record. And you just have to kind of assess the situation and make a recommendation. But when you have a situation in operations and operational control, a logbook is probably the easiest answer. It gives you a record. It gives them something to refer to. It gives you a key way of looking at it. And it also gives you something to fall back on when you're trying to make that final decision. Is this something where I just need to react and we know what happened and we're now fixing it? Or is this something where we need to elevate it and make it something more? Because a significant deviation is not necessarily a nonconformity. There has to be a criteria to go from a significant deviation to a nonconformity. There has to be a reason to find a solution, a cause. There has to be a reason. So if I don't need to find that cause, I don't need to make it a nonconformity. So how did you make that decision? decision. It may not happen while you're doing the immediate containment activity. Oh, I'm gonna turn the temperature down so I don't blow a hole in this. You may forget about it for a while. When you go back to it, you have something to refer to. So it has some advantages to have a record, so a lot of people do, but there's not a specific requirement.
And it even helps to have a procedure, right? Let's say, because if there are like two people operating it, one might term 4,000 to be a big deviation, while the other guy may see
Yeah,
4,200 to be a
No big deal, yeah, exactly. So when you have multiple people working on it, if you go and you ask more than one person who's responsible the same questions and you get different answers, that's where you need to be recommending things like, we're gonna need a record here. Or we might wanna think about some cross-training here. Or we might wanna think about a very short, very concise document here to help them. Or a checklist. A checklist is one of my favorite tools. We use a checklist here. If something bad happens, use this checklist. There's different ways to go about addressing that. But from an auditing perspective, I'm going to ask two people to do the same thing, and if I get the same relative answers, they're in the same ballpark, we're good to go. If we're playing different games, one's in baseball and one's in football, no. Got to be at least in the same park. They're attempting to play the same game. All right, so how do you communicate the criteria? How are you likely to see this? On-the-job training is probably the number one. I was trained by, Frank was trained by Joe, who was trained by Mark. Very common. Work instructions, operating procedures, you see a lot of those. Classroom training, I don't see a lot of those for operations. I do see a lot of that for other areas, but not necessarily for operations. Posted list of settings, that's actually fairly high on the list. They'll have these ranges set and posted in various places. Logbooks is probably the second most common to do OJT. Things we've learned, technology-based controls, there's no problem with those. They work quite well. They're very common these days. But they do have to know how to use them and access them. They do need clearly defined requirements, and you do need to understand what a significant deviation is and how you respond to that, what your controls are, and what the maintenance activities are. And these, again, are focused in on your SEUs. Things that we may have is documents. If they do have documents, you need to review those and see, are they current? Do they need them? Are they using them? If they're not using them, dump them. If they haven't looked at them in 8 years, they're not going to look at them in the next 8 months. They need to go away. Are they using an online system? Are they using electronic controls? Are they using some sort of software? That's where the components are going to be located. So that's where you need to go focus. They like to hide things in drawers and then pull them out during audits. Where do they get their forms? Where do they get the things they fill out? Where do they get their equipment that they're using? Has it ever been calibrated, or is it Mark's favorite gauge set from the back drawer? No. So if you say something needs to be calibrated, where are those records? All of these said yes, it needs to be calibrated. All right, so where is your TDS is a little strip they stick into a thing and it reads it. When did the reader get calibrated last? How do you know that? Now in the maintenance areas, they're grimy, they're greasy. Stickers don't stick, okay? So calibration stickers are probably not your friend, but you can try it. They don't like oil and grease, so I don't usually suggest stickers in maintenance. Stickers usually work. All right. Things you will see: alarm systems, preventive maintenance systems, PMs, logbooks. You may have an apprentice program in maintenance. That's pretty common.
What is the PM schedule?
Preventive maintenance schedule. So they might say we're going to do, motors 1, 3, and 7 today. We're going to do motors 9 through 24 tomorrow. They'll have it all scheduled out. Just because it's scheduled doesn't mean they do it though. That's the thing you have to check. And again, this all connects back to our SEUs. Because it's an SEU, it has to have operational and maintenance controls. And because we have operational and maintenance controls, we have measuring and monitoring.
Another big question on establishing the significant deviation. So when we say like this can't be above 400 degree Fahrenheit, that needs to be a background to that, right?
They may have that set for a lot of reasons. It could be set because it's in a permit. It could be set because above that it's not operating efficiently. So for example, I may have a piece of equipment that can operate over a fairly substantial temperature range. Okay, a temperature chamber. It can operate from -20 to 150 C. So it's operating over a very large temperature range. I may not be operating it except in a narrow temperature range based on the tests I do in that temperature chamber. So that may be set at that range because that's where I normally run. It may be set there because, let's say for the boiler, the TDS may be set in my permit. And if I go over that, I may have pulled it down a little bit. So if they go over it, they're able to catch it before I have to report it as a non-conformance. Because if it goes out of the range of the permit, it's a non-compliance and it has to be reported legally. So I may want to catch it before it pops out, so I may lower that limit just a little bit. So they tell me when it goes out, but it's not far enough out of the permit range that it's an actual excursion and I'm out of compliance. So it might be set for that reason. And if you're operating close to the edge of the boiler's capability, it might have excursions. And maybe one excursion a week is normal for you. If I got 2, I want you to call it significant. But yeah, they're going to have some reason they call it significant.
Right, and like it may not just be legal. So like say for example, like you walk into a facility as a CP and you see they have the criteria set up as like say 700 degree Fahrenheit for boiler. But you know from boiler specs or whatever, above 600 degree Fahrenheit it doesn't operate efficiently. So what do you do then?
You're going to kind of see why they have that range. You can make some recommendations, but in that case, if they're going to let it run to 700, you're going to say, okay, but you're sacrificing this efficiency. So this is hurting your energy performance. So if it goes over 700 at all, we really want to flag that as significant because you're already operating outside of its normal recommended range. You can try and get them to pull it down a little
So
bit.
will that be a non-conformity for when an audit comes in, or just because they have like 700 it's fine?
We wouldn't write it as a non-conformity if that's their criteria they've established. Now, as long as it doesn't violate a legal requirement.
Yeah, say it then.
Yeah. As long as it doesn't violate, we would not write it as a non-conformity. There are times when companies do decide to do things that are not in the best interest of their energy efficiency. But they need to make that as an informed decision. There's a lot of products on the market right now where the difference between product 1 and product 2, price-wise, is significant enough that they want to sell more of product 2. But to make product 2 is a lot more energy intense than to make product 1. Let's go back to our baby diapers. One of the main differences between your premium brands and your non-premium brands, and you'll see this in the advertising, is the softness. And that's a perception issue. The diaper is soft. Well, who is it soft to? Who's feeling the diaper? That's a parent thing. They feel the diaper, it feels soft, it must be good for my baby. The baby does not feel the outside of the diaper, I assure you. They feel the inside of the diaper, but not the outside. So they're appealing to a parent's response to the diaper. But it sells for significantly more. I mean, just check the premium brand of diapers versus the non-premium brand of diapers. It can be a factor of 2. It can be a significant price difference. But that takes more energy to produce. So if I'm going to make that decision, then I'm making that as an informed decision, and my operational controls are working to help me keep that energy to the best I can, but over time that is going to degrade, and I'm watching it and I'm making responses, and your significant deviation should increase as the performance of the equipment decreases. That's what an auditor looks for. Then your system is working. So that's one of the things we look for. Across time, we'll look to see if significant deviations increase. Okay. So op controls and measuring and monitoring. Yeah, let's make sure I'm in the right place. You are going to measure and monitor things that are related to op controls. This just means that things are working that you're using for controls, like your data loggers, your meters. Believe it or not, you will go out to facilities and you'll ask to see the meters. Do you have, what kind of meters do you have? Oh, we have meters on everything. Okay. So you should ask to see the meters. The other thing you want to do is see that they're hooked to something. I know I've seen my fair share of meters where you go out there and yes, at one time they were installed and they probably read something. That's not the current time because they're not plugged into anything. That happens. They can also be plugged into something else. Remember those little Kaizen people who move stuff? They don't always move the meters. So there may have been a meter hooked into something. Temperature probes are one of my favorite examples. And they moved something in the process, but they didn't take the probe because they took it out and they moved it. They never went back and grabbed the temperature probe and put it back in. So, you'll be walking along and there's this random temperature probe. You're like, oh, something got moved. And now it's hanging loose and it's, it's measuring nothing. Okay. So what are the meters? What are the data collection systems? What are they hooked to? How are they managed? Remember that measurement plan? These things should be identified on there somewhere. You can use the measuring and monitoring data to determine your performance of your SEU and to determine the efficiency, energy efficiency of that particular process. This is where your simple ratios are a lot of times used, because this is being used by the operators. If it's an SEU, you are expecting a control, you are expecting that control to work, and no, this is not an improv activity. These are planned controls, not random serendipity acts. Make sure you include maintenance. Make sure there's good communications. Make sure that you know what the records are, if there are any, and where they are, where the data is going, if they can collect data off this stuff, and look at the performance of those controls relative to the performance of that equipment. Remember, for SEUs, you have to do current and future performance. Remember energy review? So I've got the data somehow. It had to be coming from somewhere. So a part of your operational control may be to maintain that data loop for energy review. Organizations get a lot of value out of maintenance and operations. This is one area where you can actually see energy performance improvements. It's a place where you can see dollar savings. And in fact, we do have a lot of SEP case studies where this is where they've gotten all of their improvements. It's been from maintenance and operational controls. A lot. In fact, we have some platinum members. It came entirely from no investment, operations and maintenance is where they got it from. So it's an underutilized area. Your role, apply common sense and see if common sense is oddly enough not very common. Apply some common sense, some good practices, take a look at what they're doing, see how you can build upon it. Make sure you're not dumping everything onto maintenance because go see what kind of workload they have now. This may be something where you can help them get a budget from elsewhere in their organization to get some things done. Take a look at how their feedback mechanisms are working. Take a look at how they use contractors. This is an area where you can have a tremendous impact on the organization. It is something that will take a little bit of time. So, you're going to look at the KRM air compressor and see what they have and what you think they need. what kind of things you think they will have available in the audit, and what might be your audit risks you need to take care of. There is a worksheet in there that you might want to take a look at as well. Pull that up. So here is their worksheet on air compressors. We have two styles. We have this one and then this one. So you can think about either one or something completely different if you don't like this. But what would you recommend to them about compressors? We'll go back to our things we had earlier. Play with that. And if you don't like those formats, you can pick a different one. But those are there for your enjoyment.
But in a real situation, if you had absolutely no idea how to run a boiler or run some operational equipment, wouldn't you get all of this criteria from this person at the plant that knows how to run it? Or
That's a starting place. Sometimes they may just not have asked the people responsible. You can also look at the material from the OEM. Most of the time, the manufacturer's guidebooks are online.
yeah, okay.
So there are resources you can go to. There's also certified experts from DOE in these basic systems.
Okay.
And they have system manuals, like they have compressed air material
Sure.
online.
Okay.
And they've got a whole book on compressed air systems.
So
Um,
even if they provide something as a CP, you should always go back and double check everything that they provide anyway.
Well, you want to check to see if they have any, if they're following it. I mean, they may have gotten these operational controls when the equipment was installed 15 years ago, and it may
Sure.
never have been touched.
Yeah.
It's not going to be operating under those same conditions.
Sure.
Or they may have, replaced it 3 years ago, and they may have replaced 2 boilers with one,
Mhm.
based on their current needs. And it may not be anything like what they had. They may have had an electric boiler, and now they may have a dual fuel diesel and natural gas boiler, or biomass and natural gas boiler. May not be operating in the same conditions.
Okay.
So you just have to kind of sanity check.
Yeah, okay.
The paper's older than you are, it probably needs to be revised. Good starting point.
The other thing to keep in mind is, it doesn't have to be perfect
No.
to have a certified management system, and this is about continual improvement. So if they start with something, ill formed, poorly conceived, they're going to have significant deviations, right? Their operational controls or their maintenance actions are not going to really give them what they want. And so what you want to see in the management system is that they will manage that process and ultimately improve that operational control and maintenance of this, because they're getting feedback that says it's out of control through the mechanisms built into the management system. So they don't have to have it under control to be certified, but they need to start somewhere, put something down, and as they move forward, they should improve. I mean, if they're not improving, then it's not an effective system, and they didn't have really the intention of making improvements. They just wanted some paper.
You're definitely not looking for perfect. No such critter.